One of the lesser-known consequences of the Korean War was how thoroughly it accelerated the idea that materials were interchangeable as long as they met a specification. Faced with disrupted supply chains and urgent construction needs, military engineers combined whatever lumber was available, trusting fasteners and standards to overcome incompatibilities. In the short term, this worked. In the long term, it quietly erased an older rule that carpenters once treated as fundamental: not all woods belong together. Long before material science could explain why, builders knew that mixing certain species in the same structure led to warping, rot, joint failure, and early collapse. This knowledge was not written in manuals. It was learned through generations of failure and survival. When speed replaced continuity, that memory faded and the consequences became normalized. Modern builders often rediscover this problem through failure. Rusted fasteners, black staining, and weakened joints appear without obvious cause. What was once common knowledge is now treated as a surprise defect. The Korean War reinforced reliance on steel fasteners under all conditions, often without regard for long-term chemical interaction. Moisture retention varied by species and influenced rot patterns. Some woods absorb and release moisture quickly, others hold it longer. When these species are joined together, moisture migrates unevenly. One piece stays wet longer, creating localized rot even when surrounding wood remains sound. Older builders selected species combinations that dried at similar rates or isolated them physically. Modern construction often mixes species based on availability, trusting chemical treatments to compensate. Treatments slow decay but do not eliminate moisture imbalance. Insects and fungi exploited mixed species boundaries. Certain insects and fungi prefer specific woods. When structures combine species with different resistance levels, vulnerable wood became an entry point. Once established, decay spread into more resistant members. Old carpenters observed this pattern over decades. They avoided mixing durable and non-durable species in ways that created weak links. This mirrors military lessons about perimeter defense. The strongest fortification fails if one section invites attack. Uniform resistance matters. Seasoning rates mattered as much as species choice. Different woods dry at different speeds. Joining green oak to seasoned pine guaranteed movement and joint failure. Traditional builders avoided this by seasoning timbers together or delaying assembly until moisture content equalized. Post-war construction often combined materials at different stages of drying to meet deadlines. During the Korean War, rapid deployment sometimes forced the use of green or even frozen timber, leading to predictable failures later. Civilian construction inherited this urgency without the excuse of necessity. Old carpenters built regional systems because local woods behaved predictably together. Historic buildings reflect regional forests. New England frames differ from those in Eastern Europe or East Asia, not because of style alone, but because available species dictated compatible systems. When global supply chains expanded after mid-century conflicts, wood became a commodity rather than a local material. Species were mixed freely, divorced from the ecosystems that once informed their use. Compatibility was assumed rather than tested. Repair traditions reinforced species discipline. Old buildings were repaired with the same species they were built from. This was not sentimentality. Introducing a new species during repair could destabilize surrounding material. Modern repairs often mix materials freely, accelerating decay rather than halting it. This parallels military logistics mistakes where replacement parts did not match original specifications, degrading system performance over time. The Korean War intensified trends already underway. Speed, standardization, and global sourcing became dominant. Material knowledge embedded in craft traditions was replaced by generalized specifications. Builders were trained to assemble systems rather than understand materials. As long as structures met short-term performance criteria, long-term interactions were ignored. Failures decades later were treated as maintenance issues, not design errors. For those thinking beyond convenience, the lesson is simple. Materials interact over time. Compatibility matters as much as strength. Systems built from cooperative materials age predictably. Systems built from conflicting ones deteriorate quietly. In disrupted supply environments, the ability to select and pair materials wisely becomes a form of resilience. Old carpenters practiced this out of necessity, not theory. The rule against mixing certain woods was not superstition, it was empirical science practiced without formal language. Ignoring it has cost time, money, and durability across generations of buildings. Remembering why older carpenters avoided certain combinations helps restore a way of thinking that values long-term behavior over immediate convenience. If this kind of careful, historically grounded analysis matters to you, subscribe to the channel and share this video with others who value depth, context, and lessons that endure long after the structure is finished.